using the quadratic formula is what we're going to talk about now. And this is another method that can be used to solve any quadratic, no matter what. Remember, we said factoring sometimes works, using square roots sometimes works, but completing the square always works, even though sometimes it's going to be kind of messy. If your b term doesn't divide evenly by 2, you're going to have kind of a mess there, and we'd rather not do that. That's the case when I would jump to the quadratic formula. And so that's what we're going to talk about today. This is really not hard. It's basically just an exercise in the order of operations more than anything. Please note for right now, this is November 7th, 2013, that our quiz that originally I had said was going to be tomorrow is not. We're going to go ahead and move that to Wednesday. That way we can put both completing the square and quadratic formula on the same quiz. After that, we'll kind of start piecing all of this quadratic stuff together and starting to get ready for our unit test, which is going to be kind of a doozy for this one. So be kind of constantly reviewing backwards, not just the stuff that we're doing right now, but you also need to be staying current on factoring and zeros and all of that kind of stuff, okay? So we're just going to do one example here because this is pretty basic. So the quadratic formula is this, and hopefully you have seen this before. When a, b, and c are real numbers, sorry, you can hear my dog barking, and a can't be 0. The reason a can't be 0 is because it's in the denominator. We can't divide by 0. So that's why we can't divide by 0. It's really important with the quadratic formula. This only works when you have your equation written in standard form, and when we're solving, standard form means that it has to be equal to 0. We need to be able to figure out what our a, b, and c values are. That's why we need to make sure that it's in standard form and in the right order, but part of that is making sure that your equation is equal to 0. Now the formula goes like this. X is equal to, so we're trying to figure out what our two solutions are. These are going to be the same as everything else we've done. They're the solutions, they're your values for X. It's also going to tell you where your graph crosses the X-axis, which are also called the zeros. So this is telling us all of that same information by just using the quadratic formula. This is equal to the opposite of b plus or minus the square root of b squared minus 4 times ac, and then all of that gets divided by 2a. There's a song, you might have learned it before. It goes to Pop Goes the Weasel. Maybe if you're nice, I'll sing it to you the next time I see you. Okay, here is an example. So we want to solve x squared plus 3x equals 2. The first issue with this right off the get-go is that it is not equal to 0. So that's the first thing that we need to take care of. So to do that, I'm going to subtract 2 from both sides. That leaves me now with x squared plus 3x minus 2 equals 0. And so at this point, we are going to go ahead and identify those important values. Our a value is 1. Our b value is positive 3. And our c value is negative 2. Please don't forget how important those signs are. So make sure that you take the correct signs for each. And now let me put it back up here so we have it to reference. The formula is the opposite of b plus or minus the square root of b squared minus 4ac, and all of that gets divided by 2 times a. So we're just going to substitute these numbers. Where you want to be really careful, and this is like probably the best advice I can give you on this, do not try to type that entire formula into your calculator in one step. You will forget parentheses somewhere. You will come out with the wrong answer. I can almost promise you that. You have to be almost smarter than the calculator to get this typed in exactly perfectly. Your better bet is to do it in chunks and to follow the order of operations. So, for this particular example, x is going to be equal to the opposite of b. Our b is 3, so the opposite is negative 3. Plus or minus the square root of b squared minus 4 times A times C. And make sure that you draw your square root all the way to the end so you don't forget to keep all of that underneath there. And then all of that gets divided by 2 times A, which is 1. So here's the order that I always work through everything in. The first thing that I do, remember our order of operations says we have to take care of exponents first, then multiplication and division. So in the first step, I simplify 3 things. I take care of my exponents, I take care of all my multiplication here, and all my multiplication here. Notice also what's really important is that minus 4AC, that makes that 4 negative. So when you're working through and solving problems, you want to make sure you're multiplying here by a negative 4. All right? So if I do that all in one step, I get negative 3 plus or minus the square root of. 3 squared is 9. Negative 4 times 1 is negative 4, but negative 4 times 2 is positive 8. And that's all going to be divided by 2. So our last step now is to combine these two things that are under the radical, and I get negative 3 plus or minus the square root of 17 over 2. And that's the end. Remember, that represents 2 different solutions. If this were a situation where I needed a decimal approximation, we don't, because we're going to just deal with exact values. But if I needed that decimal approximation, I would have to do 2 problems. I would do negative 3 plus the square root of 17 and then divide my answer by 2. And then the second time, I would do negative 3 minus the square root of 17 and then divide it by 2. And that's how we'd get our 2 separate solutions. But for this one, this is your answer, our 2 separate solutions. And that's all there is to the quadratic formula. And it works every single time, no matter what kind of quadratic it is. It can always be solved using the quadratic formula. Okay? One quick couple of notes before you get started on your work for today is when it comes down to simplifying. Say you have to simplify radicals. Let's say that the answer I end up with is 6 plus or minus, I gotta think now, the square root of 80 over 2. Okay? Well, the square root of 80, oops, sorry, I didn't mean to do that. I meant to highlight. The square root of 80 can be simplified. There are perfect squares that go into that one. And I believe that it is 16 and 5. The square root of 80 is the square root of 16 times the square root of 5. Whoops, that should not be a decimal. That should be a multiplication. Okay, now of these two, which one is the perfect square? 16 is. That means that I get to actually do the square root of 16 and it comes out. So I get 4. And then that 5 is stuck, so it is still under the radical. So 4 times the square root of 5 is what I get when I simplify. What that gives us here then is a further opportunity to simplify. I have 4 times the square root of 5 all over 2. But here's the rule. You can only divide that 2 if it goes into all of them. Or you could reduce, like maybe it was something where I could reduce like a fraction. It didn't divide evenly, but I could reduce. I have to be able to do it with all 3 of those coefficients and constants. So here, I could divide this out. I can do 6 divided by 2, that's 3, plus or minus 4 divided by 2, which is 2 square root of 5, over 2 divided by 2, which is 1, so I could just stop here. Okay, let's say that I got something like negative 10 plus or minus 8 square root of 2 all over 6. Okay, well, these don't all divide out nicely, but I can divide all 3 of them by 2. Notice I'm not highlighting that radical because that's on lockdown. We can't change anything in there. But if the number is outside of the radical, we can. So what I can do here is I could divide each of these numbers by 2. So it's just like reducing any other fraction. I get negative 5 plus or minus 4 root 2 all over 3 because I divided everything here by 2 to reduce. Okay, so that's how we can reduce those fractions. You just have to make sure anytime you want to divide that out, you have to be able to do it in all 3 of those highlighted spots. And that is it. You have a very short assignment today. It's only 8 questions, and you have the rest of the time to work on that. All right? I will see you guys tomorrow.